Okay, let's say maybe try to do question 5. Okay, I can
Okay.
draw here. Wait. Okay, I do the question here. Okay, question 5. So what formula you have? Let's have a look. So in your formula sheet, maybe I'm not sure. Let me download your formula sheet. GC math formula. At Excel. Not this one. GC. So this is the formula booklet you always have, okay? In your any mathematics exam, even your core mathematics, you have the same booklet.
Okay.
So even you are taking core mathematics, you will still have further pure math booklet formula. So just have a look. Let's go to the further pure math. This one? Yeah. So this one, you have these two formula, okay? These two formula are given.
Okay.
But the formula summation R is not given. So that means you need to remember that formula.
Okay.
So what I mean the formula is this one. So let me capture screen of this page and then send you. 1 minute. So the formula not given here is a summation from 1 to n and then r, okay? Do you still remember the result of this one?
1/2n plus 1.
Yeah.
1/2n
Plus multiplied by.
N plus
yeah,
1.
that's it. So if you still remember, this one has a very tricky result. It's this one square. The square of this one is this one.
Yeah.
So let's see. Let me copy this screen and then. So then let's have a look at these questions. So for question 5, it's not starting from r equal to 1. So what we can do is starting from r equal to 1 to 2n, and then minus starting from r equal to 1 to n. So what?
N, just N.
Minus 1? No.
It's n plus 1 minus 1, so it's just n.
Yeah, it's n minus 2.
N minus 2.
Oh, wait, what?
So here it's starting from 1, 2, 3, n minus 2, n minus 1, n, 2, and then 2n, is it?
Yeah.
And you don't want these things. Oh, sorry. You don't want.
You want n minus 2, yes.
Yeah, you don't want these. You just want n minus 1, n, and then 2n. So you minus the summation from r equal 1 to n minus 1, n minus 2. And then you substitute in the formula, okay? And then I call it P, okay? P over 2 times P plus 1 minus P over 2 times P plus 1, okay? And then you simplify it, and then you can get this answer. No problem. But I just extract the
No problem.
1/2 outside. And then 4n squared plus 2n minus n square, and then plus 3n, and then minus 2, okay? And then you can half, and then 3n square, and then plus 5n minus 2. And then either factorize it or using your calculator, 3n minus 1, and then n plus 2. Okay, and then that's your answer. Yep, that's the answer. Okay. So do you think any question I need to go through here? Do you think I need to go through anything? Any question?
I'm seeing that.
What about the last one? Question 14.
14, okay.
Yeah.
It's not so obvious, maybe. So given that this one, express this one. So that means you need to somehow calculate A and B. So from these two, so from the left hand one, and then you can rewrite this formula as this one. From A is a constant, okay? B is also a constant. So here, that means A times 4/2 times 4 plus 1. And then here you just add B by 4 times. And then you get 10A plus 4B equal to 36. And then have a look on the right hand side here, okay? And then you actually do something similar, but it just add up to 1 to 6. So A times 6/2 times 6 plus 1 plus 6B equal to 78. So after you simplify it, and then you solve two simultaneous equations.
Okay, let us copy this.
And then from this, I'll simplify a little bit. 5A plus 2B equal to 18, and then multiply this by 3. And this equation minus this equation, 24 equal to 6A, okay? A equal 4. And then you can calculate that B will equal to -1. Yep. So if you know what is A and B, and then it's not difficult to find this one. So this one, summation R equal 1, and then 4R minus 1, okay? That means 4 times summation R equal 1 to N R minus 1 here, R equal 1 to N. This is 4 times N/2 plus N times N plus 1 minus N, okay? And then you get 2N squared plus 2N minus N. After simplify it, and then you get N times 2N plus 1. I hope it is the speed that you can do in the exam. So for part B, just N to 10. So 10 times 2 times 10 plus 1 to 10. Okay.
Wait.
So 1 minute.
Okay.
I got like A equals -8.
Really?
I thought so. Why is it 21A plus 6B equals 78? Shouldn't it be like 12A?
No, 6/2 is 3. 3 times 7 is 21.
Why is it 7?
6 plus 1 here.
Oh, yeah, never
n
mind.
over 2 times n plus 1.
I had 3 plus 1 by accident.
Oh, it's 8, 6, okay?
Okay, yeah.
If no question, then let's go on. Okay, 1, 2, 3. And then let's go on to the next topic. 7.2. Sum of squares and cubes. Actually, I don't think I need to explain, okay? You just need to use 2 more formula to solve the questions.
Yeah.
So the questions are quite similar, okay? Really similar, okay? If you look at the example 5, you just use the same trick to do all the questions. Okay, I give you 10 seconds. And then, if no question, and then let's go on to the next part. Yeah, just so simple. So then let's go on to the next part. Okay. So for question 6, actually the same. Okay. Verify is true for n equal 1. So when you substitute n equal 1 and then you summation is from 2 to 2, that means you just add up 1 times. Okay. Something similar. So let's skip. And then for example 7, the same. Okay. Then let's have a look at the example 8. You just expand everything, and then substitute summation r cube, summation r square, summation r. You get this one, and then you can find a and b. And then for this one, it's not from 1 to 40, it's from 11, okay? So starting from 1 to 40, minus 1 to 10. Okay, not difficult. So directly, let's go on to let's go on. Okay, let's practice three questions here. I don't think I need to do this one. Okay, so you choose some question. Okay, let's do together. And we're question 8. Okay, question 8. So for this question, you just expand the bracket. So you get something like this one.
Wait, which one are we doing? 7?
Question 8. I mean, no question for this one. So for left hand side, you get this one. And then summation r squared. If you forget, you need to go back to the formula. So it's 6, 1, 6, and then n times n plus 1 plus 2n plus 1. Summation r is n over 2 times n plus 1. And then here plus n, okay? And then first of all, you need to extract the common factor. Only one common factor is n. And then I will extract the 6 outside to make the formula simpler. And then you need to multiply 3 here, okay? Then you get 3. So in total is 9n. So 9n plus 1. This factor n is extracted here. And then plus 6. Any question right now? Any question right now? And then I just expand everything inside. And then simplify a little bit. And then one factor of 2 can be simplified. Oh shit. N squared plus 6n plus 8. And then you factorize once more. And then n plus 2 and then n plus 4. Okay. So you get a equal to 2 and then b equal to 4. is not the only answer, okay? Because A and B can interchange with each other. So your solution should be A equal to 2, B equal to 4, or A equal to 4 and then B equal to 2, okay?
Yeah.
Any question?
No question.
No. And then if you get this one, and then you can hence evaluate this one. And then just the same, you do the summation always from 1 to 4, always starting from 1 to 40, okay, something here, okay, minus 1 to 18.
19.
Yeah.
Or 18.
So and then substitute 40 and 80 in these formulas, and then use your calculator. You still need to write down this step, okay? This step you still need to write down. And then if you still remember, you can directly use your calculator to find this value. You can directly use your calculator to press this value. Your calculator has this function, and then it can help you to check the answer. Oh. So I'm not going to use my calculator to find the answer, okay? That's it. Or let's say, or let me just calculate the value, xc squared plus 3xc plus 1 from 19 to 40 is 22000. If you use the direct, I'm not talking about to put these in your calculator. I directly put this one in calculator. You get 220.
So it's only like the advanced calculator which you in the SKEE calculator, isn't it?
Hmm?
This is not the SKEE calculator.
The new calculator.
The new, okay.
I'll just give you a photo. So you can directly get the answer. So any question you want me to do it right now? Although most of the question, okay, I delete this page. Most of the questions are quite similar. So maybe let's have a look at maybe this one looks like more complicated, is it? This one? Yes, no.
Wait, can you wait? We can try this out, but like, give us time to do this.
Okay, maybe question 13, okay? All of you take out a piece of paper and pen and then do it. Maybe how much time do you need for this one? 5?
2 minutes.
2 minutes?
Yeah,
Okay.
I'm kidding.
Okay, okay. Let's say who finished first.
Okay.
I've also sent you the formula for R cube R squared.
Got it. Yeah, I'm getting k square n square. I got kn. Yeah, k square n square. Brackets kn bracket. I'm getting the same as show that, like 3a. I got the same answer as.
Okay, it's just go ask you to show that. Okay, if you can show that, that means you are correct. Okay.
Sir, is this enough steps? I just sent in the group chat. Send Hebrew words, please. Sorry, it's upside down.
Please send it again. Okay.
Okay.
Hmm?
What?
There's a K here. There's a K here.
Yeah.
Yeah, I meant to put it there. I did it later.
No, but you can't do it later. You should do it here. So you are almost get it correct. You also miss the equal sign in the left hand side. The equal sign here. Okay. So get equal sign here. And kn plus 1 here. Okay. And I think all of you can get the answer. Not too difficult, this one. So, okay, all of you, okay.
Yeah.
And then let's go on to this part, okay. You can directly use the result. So it's k squared n squared. Oh, sorry. K is 5, okay. That means 25 n squared. This one, you need to use the results from the formula book, okay. And then you can directly cross out the n squared because n can't be 0. So 100 equal to n plus 1 squared. Even though you know that n it should be a positive number, to be mathematically rigorous, you still need to write down true answer and then reject it. So n plus 1 can either be 10 or negative 10. So you get n equal 9 or n equal negative 11. But you need to reject this answer because n can only be a positive integer. So the final answer should be n equal to 9. Okay.
Okay.
If no question, and then let's go on to the next topic.
I feel like proof is like the hardest chapter.
Oh, finished already, or this chapter? Yeah.
Yeah, it's a short one.
So, you take some exercise by yourself. Let's finish the last chapter. Is this the last chapter?
Yeah.
Yeah.
This chapter requires so many steps.
So the last chapter, you really need to do some exercise and practice on the last chapter because it asks you to prove something. And then this we call it the mathematical induction. This is the most useful tool in mathematics to prove some formula. Of course, you may ask, how can we get those formula? Normally, just by guess. So you can see there's those few steps. I think even you have read these steps, okay, you don't understand what does it mean. Okay.
I have done this chapter and then I do understand. I have done this chapter already.
Oh my
Normally, okay, let's have a look at one short video about mathematical induction. Otherwise, you have no idea about why we need to do it like that. What that video later on. So let's get let's this one.
In the last video, we studied about inductive and deductive reasoning and introduced.
I think you have learned this in RS, is it? No?
RS? No.
Yes. So
We did?
Like
It's course.
it is examination RS.
Oh, okay.
I'm learning it.
So in the major difference about inductive and reason, just one example. All the mathematics are almost inductive reasoning, and then science are deductive reasoning.
Concept of conjecture. In this video, we shall study how. Let's consider the following expression. This expression is a sum of first n positive even integers, where n can be any natural number. Based on that expression, we come up with the following formula. 2 plus 4 plus 6 up to 2 multiplied by n is equal to n multiplied by n plus 1. How did we come up with this formula? How do we know it's applicable for any natural number n? We cannot check the reliability of the formula for all the terms of the expression one by one, as it would be very time-consuming. In order to check the validity of the formula for each term, we need a domino effect showing that if the formula is true for one integer, then it will also be true for the next and so on. What do we mean by the domino effect? Suppose you queue several dominoes one after the other. How would you position each of these dominoes in order to ensure that all of them fall when you hit the first domino? Logically, we know how to achieve our goal. But how do we write it mathematically? The best way to achieve your goal is, 1, when the first domino falls, it will hit the second one. And 2, make sure that each domino will hit the next one, and each domino that is hit will fall. When these two conditions are satisfied, no matter how many dominoes we queue, all of them will always fall. Similarly, in mathematics, to prove the formula true, it has to fulfill two conditions. The first condition is a fact, which is also called as the base case. The formula will be true if P of 1 is true for n equal to 1.
That means the statement is true for n equal to 1. So when you check n equal to 1, okay, and that means it's just for the left hand side is just 2, okay, because the last term is 2 or the first term is 2, that means only one term there. And then the right hand side is 1 times 1 plus 1, that gives you 2.
Here n is equal to 1, positional statement that has a definite value. This value can be true or false. Suppose we have the statement x is cold. Then P of x can be true or false depending on what x is. When x is ice, P of x is true, and when x is fire, P of x is false. Okay, so we know the first condition to prove a statement true. The second is a conditional property, also called as the inductive step. If we assume that the formula is true for n equals k, then it will also be true for n equals k plus 1, thus creating the dominoes effect, which we had spoken about earlier. It could also be thought of as P of k implies the truth of P of k plus 1. This assumption that we make, the assumption that the formula is true for n equals to k, is called as inductive hypothesis. To understand this better, we need an example. 2 plus 4 plus 6 up to 2n is equal to n multiplied by n plus 1. Let this be P of n. Now we will check the first condition. When n is 1, P of 1 has to be true. Let's look at the left-hand side first. When n is 1, we will just consider the first term. So P of 1 for the left-hand side is 2. Now we move on to the right-hand side. P of 1 for the right-hand side will be 1 multiplied by 1 plus 1. This is 1 times 2, which equals 2. Therefore, P of 1 for the right-hand side is also equal to 2. The first condition is done. Now for the second one. For the second condition, we first assume that n is equal to k. So what will P of k be equal to? P of k is 2 plus 4 plus 6 up to 2k is equal to k multiplied by k plus 1. Based on that assumption, we have to prove that the statement is also true for the k plus 1 case. The left-hand side of P of k plus 1 is 2 plus 4 plus 6 up to 2k plus 2 multiplied by k plus 1. How do we simplify this? Look at this part. We have already seen that this is equal to k multiplied by k plus 1. So we replace this part with k times k plus 1. We see that the part k plus 1 is common to both the terms. Hence, this can be simplified to k plus 1 times k plus 2. Now, to calculate the right-hand side, we replace the k with k plus 1 in this expression. Hence, we get the right-hand side of p of k plus 1 as k plus 1 multiplied by k plus 1 plus 1. And that gives us k plus 1 times k plus 2. Hence, we can say that the left-hand side of p of k plus 1 is equal to its right-hand side. This means p of k plus 1 is true and the inductive proof is now completed. Hence, by the principle of the mathematical induction, we can say that p of n is true for all natural numbers n.
So, do you understand what this video mean?
Yeah.
So, and even you understand what does this video mean, but we still need to get some exercise on this topic. Now let me have a look at next chapter. So next chapter is just giving you much more example. Let's see. So it divides this chapter into 4 sessions, and then each session has one kind of mathematical induction questions. So the first one, maybe the easiest one, is giving you some formula, and then you prove it by induction. So if you read different mathematics textbook, and then you can see each textbook have different kinds of structure in writing the proof by induction. So let me give you the structure I like most because it will take the least writing. So I'm not using the structure in your textbook, but you still get the full mark for this structure. Oh shit. Okay. So step 1. So you first let Pn be the statement. And then you need to copy down the formula, okay? The formula appear in the textbook. And then at step 2, so you need to, the step 2 is used to prove that the statement is true for n equal 1. So what you need to write down is, so when n equal 1, the right-hand side of the statement is something, and then the right-hand side is something, okay? And then you say that, therefore, the statement or the formula is true for n equal 1. So many words here. So what you can write down is P1 is true. And then this one replace this sentence. And then that's a step 2. And then step 3 is assume PK is true for all natural number. Or you just copy down here, okay? For copy down this statement for all positive integers. And then step 4. Step 4 is the main part of the proof. It is the most difficult part, maybe, because step 1, just the every question is just the same. Step 2, it's just substitute n equal 1, and then step 4, step 3 are all the same. So the question Step 4, say when n equal to k plus 1, and then the left hand side equal what, and then blah blah blah, and then prove that equal to right hand side. And then step 5, and then you just say by induction, Pn is true for all positive integer. Oh, sorry. Sorry, this is not for all positive integer, it's for some positive integer. So can you copy down the structure here? And then I'll give you some example.
Sir, is this recording too?
Huh?
Is this recording?
Yeah, recording.
Okay.
Well, I'll just send you a photo through the WhatsApp.
I
So,
mean, we can use this for later reference too, isn't it?
yeah. So I'll just delete this one. And then let's have a look. How can we do some of the questions? So let's say just using this question, okay? Just using this question. And then I just no. I just want to get some white space. So you want to show this formula. So so the first step is let Pn be the statement summation, and then you need to copy down the formula. 2r minus 1 equal to n squared. Okay, this is the first step. The second step is just write down when n equal to 1, and then the left hand side equal to, you just substitute n equal to 1 to here. So that means it's 2 times 1 minus 1 give you 1, okay? And then the right hand side is 1 squared into 1. So therefore you write down, therefore P1 is true. Do you have any question about this step? Step 1, step 2, and then step 3, assume PK is true for, you don't write all. You say here, it say all positive integer. You say that it's for some positive integer k. Is the step 3. And then step 4 is the main body of the mathematical induction. So when n equal k plus 1, so how is the left hand side looks like? The left hand side is summation
Sir,
of,
is it important for it to be positive integer?
because the question asks you to prove that for positive integer.
Okay.
And it needs to be positive integer, or at least integer. Yeah, it needs to be integer for mathematical induction. It can't prove some formula for all real numbers. So all the question is talking about integer. So you replace n by n plus 1 here, okay? Oh. And then now you need to use the result of this one. Assume PK is true. So I just write it down again here, but you need not to write down this one in exam. This one. That's what you assume to be true for some integer k. So for this part, and then so how can you, you need to make use of this formula, the formula here. So how can you make use of this formula? So because you assume this one is true, and then this one is made, you use this assumption to prove that for integer k is true and then k plus 1 is also true. So how can you make use of this one? So you need to think, how is this one related to this one? So this one is just a summation from r to 1 to ak plus 1. This is a summation from r to 1 to k. So you can rewrite this one like this one. 2 times k plus 1 minus 1. Do you know what I'm doing? Yeah, because you do the summation from 1 to k plus 1. So this is summation from 1 to k and then plus the term k plus 1. The k plus 1 term. And then this one, you can use your assumption. And then you put k squared here. And then you need to simplify this formula. Oh, it's not difficult. It's k plus 1 squared. So this one will equal to the right hand side when you substitute k equal to k plus 1, or when you substitute n equal to k plus 1. Okay. So therefore, you prove that k plus 1 is true. Okay. And then the last statement, you award 1 mark if you the above is correct. If you can't prove the above, you can't prove the step 4, and then the step 5 will not be award 1 mark. So step 5, by induction, Pn is true for all positive integer. So you can see when you compare this, my proof with the proof in your textbook, my proof will have less wording. You see? Okay. So even in university mathematics major, they write the proof like this one. It's more simpler. Okay. Maybe I capture screen to you. And then maybe I just do one more example, okay? And then every one of you take out a pen and pencil and then write down, do one exercise by yourself, okay? To let me see if you can get the same structure as mine. Okay, which one would you like me to prove it?
Anyone you want.
Anyone you want, which one do you want?
I have done most of these.
1, 2, 3, 4, 5, which one?
5C.
You want me to die? Of course you want me to die. You prove so much. Let's say 5B, okay? Because it's much more interesting. You have a factorial here.
Oh, factorial.
So the first step, let Pn be the statement. Okay, you don't need to write down the statement actually. And then you just copy it again here. Okay. Sorry for my writing. So it's the first step. And then second step, when n equal to 1, and then the left hand side is just one term. Your summation from r equal 1 to 1. That means the one term only. So we get 1 times 1 factorial, give you 1. Okay. And then right hand side equal to 2 factorial minus 1, and still give you 1. So you say P1 is true. So the third step is assume Pk is true for some positive integer k. And then the fourth step is the major part of the proof. So when n equal k plus 1, And then from the left-hand side is a summation from R equal 1 to k plus 1 R times R factorial. And then you can also write down the formula for the assumption in the third part. So you assume that when n equal k, it is also true. Okay. So how can you relate this part with this part? So it's adding from 1 to k plus 1. So you can write it like this one. Plus the k plus 1 term. That term is k plus 1 times k plus 1 factorial. Okay. K plus 1 factorial. And then this part is k plus 1 factorial minus 1. Plus k plus 1 times k plus 1 factorial. And then you can add these two terms together. So you get k, so this one is 1 times k plus 1 factorial. And then 1, this is k plus 1 times this one. So you get k plus 1 plus 1, k plus 2. K plus 2 times k plus 1 factorial. And then you get k plus 2 factorial minus 1. So actually this one is the right hand side one. When you replace n to be k plus 1. Okay. So the last statement by induction, Pn, sorry, you need to write down one thing more. So you say, therefore, Pk plus 1 is true. So by induction, the last step, by induction, Pn is true.
So how did you go from k plus 2 multiplied by k plus 1 factorial equals to k plus 2 factorial?
This one to this one?
Yeah.
What is k plus 2 factorial? It's k plus 2 times k plus 1 times k minus 1 up to
But
1.
yeah, I got confused from adding, my bad, sorry.
You mean this
No,
this
no,
one?
I thought for factorial you have to add all the numbers. I forgot we had to multiply it.
Because your microphone is I can't hear clearly. So
Okay.
you
No problem, no
no
problem.
problem. Okay, okay. And then okay. So let's see. Now all of you take out a pen and pencil, okay? And then can you try to prove the question 3A, okay? By induction. Now you can only use this kind of method to do question 3A. Of course, you have learned how to prove this formula, not by induction, in last chapter. But in this chapter, it's talking about mathematical induction. So you should stick to this method. If the question asks you to prove by induction, if you are not using induction, and then you get 0 mark. So everyone take out your pen and pencil, okay? To do this question and take a photo in a group and then send it in a group.
For which question?
Question 3A, 3A, 3A.
How did you do that so quick?
No. What does mean by question 1? We are doing question 3. Yeah. So you missed that. You missed the statement. P1 is true. Here. Aaron. You missed the P1 is true. And then let me have a look. So you also miss a statement. PK plus 1 is true. Okay. Aaron, can you hear me? Aaron. Aaron.
I'm lazy, okay?
No, you need to follow the procedure. Otherwise, you
It's
get,
just 2 lines.
and then
Like,
you lost 2 marks.
just because of that. That's so stupid.
Yeah, that's so stupid. But
Yeah, why?
you don't get that stupid mark, and then you are much more stupid. Is it? Yeah. Do the part 4. You just substitute the assumption or the formula in assumption, and then you can replace this part with k squared.
Sir, I misunderstood. I copied the wrong question. My bad.
That's okay. Just send
Assume
me,
and
Yep,
equal.
I checked the other questions. Correct.
just send me the question that you have done.
Wait, okay. Well, I'm gonna redo the other question because I just realized that. Sir, could you go on the question page, please?
Which one?
Yeah. Wait, that's it. That's it. I did for you.
Question 3? Okay, so let's have a look at Girard. Up to this line is still correct, okay? Yeah, but the next line you need to expand the summation from r equal to 1 to k, and then plus the kth term, and then substitute the assumption. How do you get 2k?
Wouldn't it be like 1?
K plus 1 term.
But then we simplified it, the k plus 1 term, into the k plus 1. So we should just do 1 instead of that, right?
The nth term is, the rth term is 2r minus 1. So the k plus 1 term is 2 times k plus 1 minus 1. Then you get 2k plus 2 minus 1. That is 2k plus 1. Okay.
Oh, dang. Sorry.
Any question? Ben? Ben, open your microphone.
Turn on.
Wow, it's Harry's work. And then do it. You can't be lazy, not writing. You should also write down the formula here, okay? Don't be lazy, Harry. This one is the k plus 1 term. Oh, everyone, teach Harry.
我唔想教佢。
Wait, Sid, isn't that what I did?
Hmm?
Yeah,
Isn't
we were dumb.
k plus 1 and then k plus 1 minus 1? Isn't that the term?
Yeah, it's the k term, but you don't omit this one. Oh, sorry, put it here. Okay, this one, you don't missing this part. That's okay.
Oh,
Don't be lazy, everyone.
唉，我做錯咗啲咩啊？
Wait, sir, how did you say define the rth term again?
Rth term is just the thing in the summation sign.
Oh.
This one is
Yeah.
the rth term. R times R minus 1 is the rth term.
喂，點算啊？我唔識約揀啊！
I think I get it.
And I can't help you if you can't factorize it. Let's just finish this chapter by today, and then we all can go home. You know, sleep. Okay, has any others finished?
Almost.
And you need to write down all of you missing this part. P1 is true. And then simplify this one.
Sir, it's in the next page. I sent another picture.
Okay, and then you still write pk plus 1 pk plus 1 is true. And then by
Okay.
induction,
Okay.
Pn is true for all positive integer n. Well, for all positive integer. Okay.
Okay.
Ben, you just send me this part. What have you written down in the... Ben, just send me the whole part of what you have done. Aaron, you need to know how to use your camera. Ben, where is the letter statement P? Please write the whole thing, okay? Write down everything you need to do this kind of question. You need to at least practice a few times before you can get marks in the public exam. Everyone is doing the next one. Wow, Ben, you won't be award marks if you... No one can see what you are writing. Ben, you do it later on. Write it neatly. Are the others doing? So where is caffeine? Shikut, Diana?
Wait a sec.
Oh, and also, do you see Paolo? Paolo seems missing. Hmm?
Paolo is like with Diana.
I'm
Your
missing.
siblings.
I know, but Paolo has not handed in the homework and not replying the WhatsApp, something like that.
Oh, I don't use my phone.
Yeah, you need to reply me. Let me see. Have you filled in the form? Let me see who haven't filled in the form.
Yeah, probably me and Diana.
Yeah.
Wait, what form?
You need to set up. You need to fill in the form.
Today, sir. Sorry.
Oh no, it's the form for the Form 5 GCE.
Oh, for physics?
Yeah, for
Yes,
physics.
hello.
Oh, okay.
You still need to fill in the form. Hello.
Yeah, okay. What's the-
Oh, how many have filled in? Is it who haven't filled in? Can you check the name?
21 20 wait.
No,
20
Micah,
students.
just fill in once more. So
Okay.
there is 19 people here. So with hello and then 20, and also one missing.
Huh.
Who is missing here?
Okay.
Okay. Who is missing here except hello?
So Gerard didn't answer how long it takes to go to school.
Gerard? Is it Gerard?
He didn't answer how long it takes to go to school.
No, Gerard's name is not here. Oh, Gerard.
No, it's there.
It's okay. It's okay. 45 minutes. No? So who?
Is
So
it
can you have a look? Who is missing here?
Is it Zachary?
Zachary here.
Zachary.
Oh, so, yeah, Zachary. Okay. And then I'll talk to him. Yeah, I asked him. Okay, and then he told me he will fill in few seconds. And then So okay, can we go on to the next topic?
Yeah.
So this topic is still talking about mathematical induction. Let's prove something else. Is you can proving divisibility results. Okay, let's say, but you are still using similar structure, okay, but not exactly the same. So proof for induction that for all positive integer n, this one is divisible by 4. So I will just draw a write down similar structure, okay? I'll write down here. So still step 1, let Pn be the statement, okay? What statement it is? This one. There's no formula here, okay? You can't see equal sign here. So 3 times 2n plus 11 is divisible by 4. If you want to be a little bit lazy, okay? In mathematics, there is one symbol. Let me actually I forgot how to this one. So in mathematics we have a symbol. Why I can't see here? So there is a symbol like this one. So when n is divisible by xe, we use this symbol. You can use this symbol, but I rather you not to use this symbol because it's quite confusing. So for 4 is divisible by this one, the symbol will look like this one. And the major thing, why I ask you not to write this like in this symbol, because the marker may not recognize this symbol. For those marker who does not study mathematics as a major in university, he or she may not recognize this symbol. So just
there gonna be markers who don't study math will be marking up papers.
No, I don't think so.
Sounds about right.
I don't think so because even he or she study mathematics, you can't ensure that he know or she know this symbol. Yeah, especially for some for those graduates from some countries developing developing countries. So don't take this risk. So let Pn be this statement, and then next step. So when you say when n equal 1, and then 3, there's no left hand side and right hand side, so you don't need to write down left hand side, right hand side. You just put in 1 here, okay? 3 to power 2 times 1 plus 11, okay? And then you get this value, okay? This is 9 plus 11 is 20.
20.
So you better write it like this one to show that 20 has a factor of 4. So you say P1 is true, okay? And then the next step you need to a little bit so assume Pk is true for some integer. Okay, I rather you to write down like this one. I rather you to get a little bit one, you can say one more step in this kind of question. So when you say that it's true for some integer k, so you need to replace n by k, okay? And then it is divisible by 4, so you can write down it's 4 times some integer for some integer m. This can simplify your calculation later on, not like this one. If you write down something like this one, you need to carry out this thing all the times. And then this is so tedious proof. So let me show you why I write down something like this one, and then it can simplify your proof. So let's say, and then when n equal k plus 1, and you want to prove that this statement is true when n equal k plus 1, if k is true, pk is true. So when n equal k plus 1, that is 3 times 2 times k plus 1 plus 11, okay? And then you need to think, you need to think about the relation between this one and this one. So that means how can you substitute this formula into this equation? That's what you need to think about. So what I will do here, okay? 3 to the power 2k plus 2 plus 11, okay? And then I extract the plus 2 outside. That means it's 9 times 3 to the power 2k. Any question here? No?
No.
So therefore, I can substitute this formula inside here. So you have 3 times 3 to the power 2k. Then that's equal to 4m minus 11. Okay. And then 36m minus 11, minus 99 plus 11, okay? And then you get 36m minus 88. And then you can extract the factor of 4 outside. So therefore, you say that, therefore, pk plus 1 is true. Okay? You can see that my calculation is a little bit more simpler than the one in the textbook. Okay. So you say pk plus 1 is true. So and then the last step is by induction. And then Pn is true for all positive integer. Okay, any question? So let me copy down this page. Cap screen. Okay, and And then let me do one more example and then you do it by yourself. So I think this one, it seems like so complicated here. So while if you look at the steps here, okay, you will never want to do this question again. So let's say how can we do it simpler using so-called my method, okay? So the first one, let P be the statement, okay? I'm not copying down the statement. You need to do it by yourself. So let's say when n equal 1, 11 to the power 2 plus 12. Yeah. So you get 1, 3, 3, okay? So let's say P1 is true, okay? And then assume this one is true for some, PK is true for some integer, or for some positive integer k, okay? And then the major part, let me do, oh, sorry. And then you need to add one small step. So that is 11, well, you just write down what is k, pk. pk is 11 to the power k plus 1 plus 2k plus minus 1 equal to 133m.
Okay.
The next part is the most difficult part I can think of. When n equal k plus 1, that's the 11 to the power k plus 2 plus the 12 to the power 2k plus 1. Can you see why?
I can see why.
And then the next step is think of method to substitute this one inside here. So it's not too easy to see. So if you,
Do we use
because
log?
no, it's too complicated. You take log. So if you let me see, show it down. This one and this one are quite similar. You can see, and then this one and this one is quite similar also. So we can either substitute in the into this one or this one by, of course, doing some small.
11 squared plus 11 to the power of k.
No. If you put square here and then, because what I want to make this term to be the same as this term, so you just
We can do 11 times 11. Okay,
equals 1, okay, and then you get the same term here. And then the next step is substitute this formula inside here. So it's 11 times 11 to the power k plus 1 is 133m minus this one. Okay? And then you get 11 times 133m and then minus 11 times. So this one already has a factor 133. And then you just need to see how can you get 133 from these terms. So what you need to do, just like in your mathematics, to make some common factor. So they all have the common factor 12 to the power 2k minus 1. So I take out 12 to the power 2 to make that they have the same common factor. Okay. And then here is 12 squared minus 11. 12 squared minus 11 is 133. 2k minus 1. And then you need to make 133 outside to make it a bracket, okay? And then you can see now A has a factor of 133. I think my method is much simpler than this one. You can,
I agree.
yeah, it's so
Yeah.
complicated here. So that's how you should do in, and then the last step by induction. And then Pn is true for all positive integer.
So don't we first write P holds true plus 1 hold true?
The first step, let Pn be the statement. The second step, prove that n equal 1 is true. Oh, sorry.
So do we have to write down
Okay.
stuff like here, like 133, and then brackets 1 here? Stuff like
no,
that.
no, 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 don't need. Yeah, you can do it, but it's okay. Of course, any number is a factor of itself, so don't need to write it down. So I missed a step here. Okay, therefore pk plus 1 is true. Okay. So the next one, of course, do it by yourself. Let's do one question by yourself. So, okay, sure. Let me, okay, cap screen. And then let's go on. So, which one would you like to do? Maybe each of you do 2 questions, okay? Let me copy or just send this. Question 4. And maybe also just do one in above. So let's
Which
say
number is this?
question 4. And let's say this one, G, okay? So take some time to do it by yourself. Question 4, so maybe just highlight the one here. This one and this one. So just follow the steps.
Sir, when we say at the start, like let Pn be whatever the statement is, do we have to write down divisible by 6 as well, or whatever?
Yes, yes. What do you mean the first step?
Yeah, like the very first
Yeah,
thing.
yeah, you need to write, so let Pn be the thing I highlighted.
Okay.
Wow, everyone's so fast.
He's hacking.
Like as X. He does true. Nice.
So everyone missed something, okay? Therefore, pk plus 1 is true.
Wow.
The other is perfect. Let's miss one part, okay? Okay, this is almost a perfect answer. And then Anyone finish?
No.
Oh, so sad. Wow, A1 so fast. Mm-hmm.
I'm confused.
Which one?
For 1G, I'm slightly confused because I'm getting 6m plus 3 multiplied by k squared.
Can you photo what you have done? Yeah, instead of just telling me.
Okay.
Aaron, how are you so fast?
So you miss P1 is true here. You miss P1 is true. And then PK plus 1, okay.
Okay.
And then, okay. So this kind of question is quite, mathematical induction is quite not too difficult. Because you can, if you can prove it, and then almost you can get full marks if your structure is correct. So not like those questions, not like those calculation questions, because for those calculation questions, you are not sure that if you are true or not.
Sir, can you tell us how to do 1G? I tried and I'm getting
You just
very
have a look at everyone's answer. Hush.
You forgot to say P1 is
No,
true.
I'm confused. I'm getting like a very weird answer because it's. I was confused. That's why I sent it.
Mm-hmm. Mm. You almost get the answer. So for this part, and then okay, let's see how everyone's do it. So why?
Aaron did a different one, I think.
Okay.
He's doing like a totally different question.
So 1G is a bit So your step is correct. And then you need to argue one more thing.
Oh, okay.
So what you should argue that you can have a look here. You get you want to extract a factor of 6. So wait a minute. Now, what you need to argue more is if k is odd number, k squared plus k is even number. Okay.
Okay.
If k is odd number, k squared plus k is even number because k squared is still odd number. And then odd number plus odd number is even number. Therefore, k squared plus k plus 2 is even. So you can extract a factor of 2. And then if k is even, k squared plus k plus 2 of course is even. Okay. That's how you do it.
Okay, so I have to do something else.
Hmm?
Wait, can you explain that again?
So let me write down here. So you need to write down one more argument. So let's say, so this one you want to extract a factor of you want here to be a factor of 2.
Yeah.
So let's say you say if k is odd, k squared plus k plus 2 is even. You don't need to write down so in details. So and then if k is even, and then k squared plus k plus 2 is also even. So, and then you say that therefore 6m plus 3, this one, has a factor of 2, well, has a factor of 6. What does mean by oh yeah k?
That was to me. Don't worry about that.
Okay.
I know it's wrong. Just doing it again.
Yeah. And then so shall we go on? So if you can have a look at everyone's answer.
Oh wow.
So shall we go
Okay.
to next session? Okay. And then for the next session, is proving some recurrence relation. So just like the sequence of this one. So you have a look at this. Do we have this kind of sequence in core mathematics?
Yeah, we have learned recurrence
I think you have learned it in IGCSE also.
and IGCSE. We learned it this year.
So it asks you to show that the general statement of this one give the same first 5 terms of the sequence. So what? Okay, skip the last one. So I already look at this example. Can I just maybe you just have a look at this statement. So you are not the first step. You can let Pn be this one. Un equal to 3n minus 2. So I'm lazy. I don't want to write it down here. But so the first one, let Pn be Un equal to 3 to power n minus 1. And then this one, the previous one, you say that you prove that any one n P1 is true. But this one, they already given you P1. So you need to prove that n equal to 2 is true and n equal to 1 is true. And then I don't know how to explain, but you need to prove that P1 and P2 is true also. So you say with n equal 1, and then you get when n equal 1, and then you get from this formula, and then you get 3 to the power 1 minus 2 equal 1. And then when n equal to 2, and then you need to use recurrence relation. And then U2 is 3 times U1 plus 4. And then that is 3 times 1 plus 4, that's 7. So it's equal to 3 to the power 2 minus 2. So you say that P1 and P2 is true. And then you do the assumption, okay? Assume Pn is true for some positive integer k. And then the next step, so when for pk is true for positive integer k, that means uk equal to 3 to the power 3k minus 2, okay? And then you just do something like this one when n equal to k plus 1, and then prove the following. So you use this recurrence relation. Do you know why I substitute, instead of substitute n to be instead of substitute nu to k plus 1, I just put it here is k plus 1 is not k plus 2 because I want to prove that pk plus 1 is true. So for pk plus 1, that means the term uk plus 1. And then first of all, you use this recurrence relation. And then after you use this recurrence relation, and then uk, you substitute the formula here. 3 times 3k minus 2 plus 4. And then you can get 3 to the power k plus 1, minus 6 plus 4, that means minus 2. And then, therefore, you have proven that pk plus 1 is true. And then the last step by induction, Pn is true for all positive integer. And that's it. I'm a little bit lazy now. I don't want to write down so many things. So let's see. This is not, I think it's not too difficult. But can you just do one question, okay? Maybe question 4. Question 4. And then see if you can get this result. Question 4. Now, it have given you U1 and U2. That means you need to show that U3 is true. That means P3 is true. So try to do it by yourself first.
Oh. Sorry, I don't know how to do the steps. I forgot it.
So,
I went to the washroom. What do we have to do?
okay,
What do you have to do question 4?
Yeah.
Okay.
Let's do it together.
Okay.
Wow, it's almost 3 p.m.
Oh, wow.
Okay. So first step, let Pn be the statement. Okay. And then you need to show that NU1, NU2, and NU3 is true. NU1, U1 is given already, this one. But you need to show that this formula can show you the result.
Oh.
Okay. That means P1 is true. And then when NU2 and then U3 to power 2 and minus 2 to power 2 give you 5, okay? And then let's show you that P2 is true. But why you need to show that P3 is true also? Because you haven't used the recurrence relation. So by using the recurrence relation, and then this is 5 times u2, okay, plus 6 times u1. Oh, sorry, minus 6.
19.
Then that's equal to 3 to the power 3 minus 2 to the power 3.
Yeah. And then do we just write therefore P of n is true?
So therefore, you say it therefore P1, P2, and P3 is true. And that's the first step. And then the second step. The third step is assume pk is true for some positive integer k. So that means uk equal to 2k, also 3 to the power k minus 2 to the power k. And then fourth step is prove that this one is true. So NUK plus 1 by using the recurrence relation. UK plus 1 equal to 5 UK minus 6 UK minus 1. Okay.
Yes.
And if no question, and then let's go on.
Hello.
Well, what do we do after that?
Wait for me.
Wait, don't we use like 5 UK minus 1?
Each basically n plus 2 equals k plus 1. So yeah, what's up?
Oh, okay.
Okay. And just replace n plus 2 by k plus 1. So this one is k plus 1, and then you can see minus 1 minus 1. So k plus 1 minus 1 is k. K minus 1 is k minus 1. So, and then you substitute these assumption here and here. Now, here you are not substituting directly. You need to replace k by k minus 1. And then you need to simplify these formulas, okay? So for 3 to the power k is 5 minus 6 times 1 over 3. And then minus 2 to the power k, 5 minus 6 times 1 over 2. And then therefore you say pk plus 1 is true. And then, so by induction, Pn is true for all positive integer n. That's it. Okay, any question?
What? So I don't get like the last bit, like here.
So let's say,
Like how do we get from here to here?
from here, sorry, you mean from
He's asking
from here to here? No,
No, the next one.
2 times 2 to the power k wall. That means 2 times 2 to the power 1 times 2 to the power k wall.
Yeah, that's 2 to the power of k plus 1. But like, how did we even get to 2 times 2 to the power of k?
5 minus 6 and times a half is 2.
Oh,
Yeah.
okay, I see.
Okay.
Okay, never mind.
So if no question, and then but it's over 3 p.m. So some of you need to have another lesson. So maybe let's finish it by next time, okay? Next
Okay.
time. So I just copy it down. And then next time let's do some revision on FP1, and then you can do the past paper. Yeah, almost finished. Okay. And then maybe let's have lesson on Monday. Monday. Okay. Maybe let's discuss the time in WhatsApp.
Okay.
Okay, let's say Monday, but Monday afternoon. Okay. See you. Bye bye.